Happy Teacher Appreciation Week and welcome to the Elliott Hand Network. I'm your host, Charles. The Washington Teachers Union has just launched a major initiative called Learning Doesn't Stop Lessons on TV. Our first class will be conducted by Mr. Bonhomme from School Within Schools, and our second class will be conducted by Nadia Torney from Kimball Elementary School. Let's see what we can learn today.
How's it going, everybody? How you doing? My name is Raphael Bonhomme. I'm a third grade teacher at School Within School. But today, what I'm going to be giving you is a second grade math lesson. Now, even though it's second grade, doesn't mean that third graders, first graders, even some fourth and fifth graders might not learn anything. Some adults out there, you might learn something new also. Once again, my name is Raphael Bonhomme. Follow me. I have a lot of great math stuff that you can learn from. And also, this lesson, in every lesson that I've done before, I'm here every week, is on this website, WTUlocal6.net. A lot of great videos, a lot of great lessons. Check them out if you've never seen me before, or if this is your fifth time seeing me, whatever the case may be. Anyways, let's turn our attention down on my board and let's get busy. So today what I want to do is expose you to these words, adding and sum. I'm going to be using these words throughout the lesson, so I want you to pay close attention and don't forget what they mean. Adding, those are numbers combined or added together, and a sum is the total or result of adding two or more numbers together. Don't forget those. What we're first going to do is a warm-up. And my lesson today is about addings, not two, not three, but up to 4 addings, and how we can have fun with numbers and play around with it. Not some boring old school stuff. Now, what we're going to do that's very important is knowing what makes tens. So, at home, you could be writing this down too. Practicing this, parents. You should be practicing this with your kids every day and just quizzing them a little bit. And I'll show you, because the number 10 is very, very important. Very, very, very important. Look, I have one add in here, but there's a mystery to figure out what this sum is, which is 10. Now, for each one of these equations, you will start to see a pattern. And it's important that you know this pattern. 1 plus 9 equals 10. 2 plus 8 equals 10. 3 plus 7 equals 10. 4 plus 6 equals 10. 5 plus 5 equals 10. 6 plus 4 equals 10. 7 plus 3 equals 10. 8 plus 2 equals 10. And 9 plus 1. And vice versa. You can see that these are connected and these are a pattern. If you switch these two addends, they still equal 10. Practice this at home. This is very, very important. Numbers between 1 and 9 and how they combine to make 10. Practice that. I'll get back to that. Now, in our lesson today, we're going to have different addings. I'm going to try to show you with some base 10 blocks also, so you can see it in multiple ways. That means more than one. The first problem that I'm going to put up here is 37 plus 46. So what I want to do is show it to you with these base 10 blocks. 37, that's 3 10s and 7 1s. So 3 10s and 7 1s. 1, 2, 3, 4, 5, 6, 7. And here I have 46, which is 4 10s and 6 1s. 1, 2, 3, 4. And then we have 6 1s. 1, 2, 3, 4, 5, 6. Those are the 6 1s. Now these are just two add-ins I said we're going to get up to 4 add-ins. Hopefully, if we have enough time, if I stop talking so much, we'll get there. Now, the thing about making tens, like I've shown you in previous lessons, is very, very important. I put a T and an O on top so then we remember the ones and the tens. Ones, tens. These are ones and these are tens. So it makes sense. Making tens. Now, in previous lessons, I've told you, look at the add-in that's closer to the next 10. When we look at 37 and we look at 46, or when we just look at 7 and 6, if we focus on the ones, which one is closer to becoming the next 10? It will be 37. So, like I was practicing before, I need 3 more to get to a 10. So what I'm going to do with this 46 is turn it into a 43 and a 3. So I have 43. And these 3, I'm going to combine with this 37. So instead of a 3 and a 37 now, this is now 40. 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So this has become 10. This is 40. Now it's basically 40 plus 43, which I have here. This is much easier than 37 plus 46. Now I can just combine the tens. 40 plus 40 equals 80. So it'll be 80, and then I have 3 ones, which is 3. Let me give you another example of how to do this. This time, I'm going to use 3 add-ins when I am doing my addition equation. Oh, sorry, I forgot to circle my sum, which is the result of when you combine add-ins together. And I like to put a crown on my final answer. The next problem or example that I'm about to show everybody is 24 plus 27 plus 28. Now, a lot of you may be used to adding like this. This is standard algorithm, or some people say stacking or vertical form, but this is not having fun with math because this is boring. Real boring. We could do this in a very creative way, and I'm going to show you how. 24. I have 2 tens, and I have 4 ones. 27. I have 2 tens, and I need 7 ones. 1, 2, 3, 4, 5, 6, 7. Perfect. And then I need 28, which is 2 tens, and I need 8 ones. 1, 2, 3, 4, 5, 6, 7, and 8. So remember, these are 3 add-ins. 1, 2, 3 add-ins. And they're all double digits. All have 2 digits. Ones, tens, ones, tens, ones, and tens. I may be going quick, but remember, you can always check that website and watch this video again and keep on watching it. But let me continue with this. We have 3 add-ins. I want to have fun with this math. Like I said, it is very important that we try to make a 10. So what I'm going to do is look at which one of the ones place, and I'll do it in purple. Which one of the ones place is closest to the next 10? That's how I like to do it. It looks like 8 is closer to being the next 10. And it's 2 away. Remember, 8 plus 2 equals 10. So, if I have 28 down here, I have my 27, and then I have my 24, I'm thinking about taking a 2 out of this 27, 2, which means what I'm left with over here is 25. I want to take this 27 and turn it into a 25 and a 2. Now I'm going to bring this 2 over here, 2 and 28. Now I have 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Perfect. This is now a new 10, which means that this is 30. This is not 28 anymore, and this is not 2. They combine together to make 30. Now, over here I still have a 25 and I had this 24. If I combine 4 and 5 together, can I get me to a next 10? Nah. So what I'm going to do is just continue to add these together. I want to combine my ones. 1, 2, 3, 4. So I combine the 4 ones, which is here, with the 5. 1, 2, 3, 4, 5. 5. And I combine them together and I make 9. So I have 9 ones over here. What means I'm left over here with a 20 and here with the 20 also. So I have a 20, I have a 20, I have a 9, and I have a 30. What I want to do now is just combine all my 10s. 20 plus 20 equals 40, and I cross those out because those are not 20s anymore. I combine them, those two add-ins, to make 40. And now I want to combine this 30 all the way with this 40, which is kind of messy, but now we could just skip count by 10s. 10, 20, 30, 40, 50, 60, 70. So here I have 70, and all I'm left with is my 9. So when I combine the 40 and that 30, it makes 10, 20, 30, 40, 50, 60, 70. All I'm left with is 70 and this 9. Now I can combine those together, and that's easy. 79. It was a little bit difficult to show with the base 10 blocks, but I wanted to make sure that you can see how I made 10 a next 10, and then I combine all my other numbers. It might seem a little bit messy, but it's a cool way to have fun with math. It looks like my time with you is up. I'm sorry that we couldn't get through the entire lesson, but please make sure that you go to this website, WTULocal6.net. My name is Raphael Bonhomme, and it was a pleasure, and hopefully you'll see me again next week and learn some more math. Remember to follow. I have a lot more math lessons. I'll see you next time.
Oh my goodness. Friends, you're here already? Oh, guess what, guys? I was busy in the lab. Oh my gosh, I'm so glad you're here. I almost missed you. Whew. Well, it's Miss Torney, and I'm so glad to be with you all again. I need to know who's out here. You know how we do every week, okay? So we're going to take attendance in our special way. I'm going to say, what's your name? And you're going to tell me your name nice and loud. Then I'm going to say, how do you feel? And you're going to tell me how you feel nice and loud. Are you ready? Here we go. What's your name? My name is Miss Torney. How do you feel? I feel electric. What's your name? My name is Miss Torney. How do you feel? I feel electric. Oh my goodness, I'm so excited to see some of my friends are back from the last couple of weeks. I see my friend Kimball and Maurice. Good to see you. Aiden and Andreas and Amari, you all are here. Yes, Marissa. Welcome. First time you're here. And Frank, awesome. I'm so glad you brought some new friends, new parents with you today. Whew. I know you were wondering, why on earth did I have my goggles and my lab coat on? You know, as I was preparing for you all today, I realized something. I bet you guys knew it all the time and nobody even told me. Did you realize that all this time we've been doing our ELA work, we've been talking about science? Oh my goodness. I had no clue. When I was preparing for you all today, I looked up something and it said the science of magnets. Oh my goodness. I was like, this is incredible. Yes. So, yes, although we've been talking about nonfiction, we've also been talking about science, magnets, and magnets equal electricity. I know. Amazing. I was shocked myself, but I was totally excited to hear about that because now we can find out more wonderful things about magnets. And so in the last couple of weeks, we've been talking about all kind of magnet vocabulary, right? We talked about what? Push and pull. Yes, the magnetic forces. Yes, attraction, repulsion. And then last week we added levitation, right? All of these are words about magnets, but they're also words that tell us something about science, which is electricity. Boy, oh boy, you can't believe what we're going to learn about today. So we are adding 2 more words to our vocabulary list. All right. That would be energy and electricity. All right. So now, oh my gosh, I was wondering, how do we put together energy and electricity? Well, energy is all about how we get some kind of utilization of a resource, right, to make it do something. And then electricity is about how we take that resource so that it can create work, it can complete a task. Think about that. What kind of tasks do you have to do at home that require your use of some type of electricity? And now remember that maglev train, right? Yes, that maglev train that we had. And it was creating work, right? Yes, because someone was going back and forth to work or home, right? Some kind of work being done by that maglev train. But it was the work of magnets using levitation. Now we're going to learn about different ways that we can use energy and harness energy and what types of energy there is. So that maglev train was electromagnetic energy, right? What other kind of energy do we have? Natural energy. Bet you know what that is. Chemical energy, mechanical energy, and electrical energy. So let me give you a couple of examples of all those things. So first, natural energy. Do you see this? When I was in my lab, I tried to make sure that I could make this work for you. So one of the forms of natural energy would be light, right? Or fire. So I can show you how we can create some energy here. I'm going to light this up. And what happens when I put the fire on the wicks of my candle? Oh my gosh, do you see this? What do we have? We have light. And I'm not going to touch this. Why am I not going to touch it? Because not only do we have light, but we also have heat. Both 2 types of natural energy. Well, I'm going to put this over here where it's safe. Now, I want to show you another type of light. What happens when I turn this lamp on? See, it's off now. Now I turned it on. It's off. Now I turned it on. What kind of energy do you think that was? If you said electric energy, you were right. Because there's a cord, right? I have a cord that connects my lamp. And it runs a circuit from the lamp itself all the way to the outlet in my wall so that it can get electricity. Yes. And so now there's a difference between those two types of light, although they're both light, natural and electronic. I'm going to use another type of energy right now to blow these candles out. How do you think I'm going to do it? Should I run outside and let the wind blow? That can do it. I could create my own energy, and I could create a force like the wind by blowing. What happens when I do that? See? No more light and no more heat. It's all gone. I know. Incredible. Now, the next type of energy we'll talk about is chemical energy. I bet you didn't know that this creates chemical energy. Yes, what is it? An apple. Yeah. Oh my gosh. And in my apple, I find tons of energy because what I'm going to do is bite my apple and it's going to feed my body, right? And when I feed my body, I'm going to get energy. I'm going to be able to run and walk and play and even dance, right? Because the chemicals in the apple are going to come into my body and create energy. Oh my gosh, incredible. I have another natural source that I want to show you. I bet you don't know what this is. And what do you think is in here? Well, look what happens. I have this. I'm going to move it like this. Do you see what's happening? What do you think is in my toy? It's water. And it's creating energy, right? Is there something happening? Yes, it is pushing my ball around. You see that? It's almost like a water pulley system, right? That water goes round and round and round. And then it creates all this movement. It's really cool. And I have to tell you, I'm glad my son let me borrow this so I could show you. It's amazing. And it doesn't require any other type of energy, right? It's no cords, just the water. Super, super, super. How about another form of energy? Why do I need these? Do you know what these are? Ever seen these? Let me see. What do you think Miss Torney looks like with these? I'm going to be able to use them later on, huh? Yeah, my sunglasses. And what is it protecting me from? The energy, the rays of the sun. Yes. Oh my gosh. You guys are the smartest people ever. Just brilliant. Your teachers are the luckiest teachers ever because I know that you're providing them all this information. They must be amazed at what you're bringing. Yeah. So, yep, that's from the sun. So, all these types of energies, we can use them right here at home, right? We talked about them all, right? The sun, fire, wind, and water. Talked about all of those right here at home. Now, since you've been home, I bet you realized, Miss Torney, we've been using electricity all along since we've been learning from home, haven't we? What kind of things have we been using? Yes. 2 snaps up. You got it. Let's see if some of the things that you've been using are the same as mine. So I've been using lamps. Yep. I've even been playing on my game system. Yes, with my children, we play games. I like to play games too on my free time when I'm all done with work. Yep. What else? My cell phone, of course. I know I have to keep my cell phone charged. So it has to be plugged into what? Electricity. Yes. And of course, my TV on my large big screens, right? Because that's how you guys are watching Miss Torney on your TVs. Yeah, so all of those things we've been using all along. So isn't it great that we can read about it and it's going to make sense to us because we've been using them. So once again, I'm going to turn you back to your readings in your distance learning plan, right? And as you are reading, You're going to use all of these strategies that we've been talking about, right? You're going to underline, yes, the main points. And this time I want you to look for the word energy and look for the word electricity, because those are the new words we learned. Yes. And what else? You're going to circle anything that's not clear, okay? Anything you want to ask your children, your teachers about when you're in class with them. What else are you going to do? Put a question mark, yes. Anything that you want to get some more information about. And then don't forget, use those margins for your notes. That's a great place to remember what you want to say when you're talking to your teachers all about your great reading. Right? So now, remember, my second graders, I'd like you all to walk around your house and see how many different forms of energy that the people in your homes are using. Are they using chemical energy? Maybe when you're eating breakfast, right? Or any other types of energy, right? How many electrical outlets are in your home? Now, don't touch them. All right, I just want you to count using mental math so that you can realize how much electrical energy your families are using. And my third graders, you're going to go into your distance learning packet and read all about how we harness different forms of energy to be able to create electricity. I tell you, guys, once upon a time, I used to have a favorite song. And I thought about it today because it's called The Electric Slide. Oh my goodness. I'm going to start it. Because I'm going to eat my apple and I'm going to have enough energy to do the electric slide today. All right. So my friends, I will see you next week. I'm getting ready to have my snack and do the electric slide because I feel electric. See you next week. It's electric. Bye-bye.